So this problem is from the 2011 Form B exam, and what it asks you is this. Basically, it's given you the function ln of 1 plus x cubed, and it's telling you in the first part that the Maclaurin series for ln of 1 plus x is all this. Okay, so it's already told, and it wants you to use this series to write the first four non-zero terms. So a lot of work has already been done in the problem, which makes life a little easy. So the first part, it wants you to write the first four non-zero terms. So you've been given this ln of 1 plus x is equal to x minus x squared over 2 plus x cubed over 3 minus x to the 4 over 4 plus dot 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 minus 1 to the n plus 1 x to the n over n plus dot dot dot. Now, if you notice this very carefully before we go into the problem, you see that if you replace x with 1, okay, you end up with the alternating harmonic series, and the sum of the alternating harmonic series happens to be ln of 2. So just an extra piece of information there. Okay, so let us write down the Maclaurin series for our function f of x, which is ln of 1 plus x cubed. Okay, so all we're going to do in this is replace each of the x's with x cubed. Okay, which happens to be, say, the first term will become x cubed, the second term will become x cubed to the power 2 over 2, the next term is x cubed to the power 3 over 3, minus x cubed to the power 4 over 4 dot dot dot. The nth term is minus 1 to the n plus 1, x cubed to the power n over n plus dot dot dot. Now, this it happens, when we simplify, this becomes x cubed minus x to the 6th over 2 plus x to the 9 over 3 minus x to the 12 over 4 plus dot dot dot. The general term is x to the 3n over n plus dot dot dot. So this takes care of part A of the problem. Okay, let's look at part B now. In part B, so here it wants us to find the interval of convergence. We've been told that the radius of convergence is 1. It wants us to find the interval of convergence. What we have, if you look at this function here, uh, if you were to do a ratio test, okay, then it tells us that the ratio of the n plus 1 to the nth term, okay, which happens to be x to the 3 n plus 1 over n plus 1 times n over x to the 3n, okay, this happens to be equal to x cubed, okay, and we want this x cubed to be less than 1, which implies that we want x to be less than 1. And so what we have is that we know that the interval is going to be centered around 0. It'll be within 1 and minus 1. We need to test the series at the endpoints. Okay, so at minus 1, at x equal to minus 1, we end up with the series which is we end up with the series minus 1, minus 1 over 2, minus 1 over 3, minus 1 over 4, okay, and so on, which happens to be simply the harmonic series, okay, which diverges. On the other hand, at x equal to plus 1, we end up with 1 minus 1 half plus 1/3 minus 1/4 and so on, which is the alternating harmonic series, which we know converges. So therefore our interval of convergence is minus 1 less than x less than or equal to 1. Okay, so now let's go on to the next part of the question. So in this part, it wants us to write down first the first four non-zero terms of the Maclaurin series of f prime of t square. Okay, and once we have that, then we'll do other things. So first, let's once again write down what f of x was. The f of x for our series was equal to x cubed minus x to the 6 over 2 plus x to the oops, x to the 9 over 3 minus x to the 12 over 4 plus dot 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 minus 1 to the n plus 1, yeah, times x to the 3n over n and plus dot dot dot. So this is f of x. So once we know f of x, we can evaluate f prime of x. And here we simply differentiate it term by term. And f prime of x ends up becoming 3x squared minus 6x to the 5 over 2 plus 9x to the 8 over 3 minus 12x to the 11 over 4 plus dot 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 minus 1 to the n plus 1, 3n x to the 3n minus 1 over n, and plus so on and so forth. And you see that this ends up becoming 3x squared. So this is f prime of x. 3x squared minus 3x to the 5 plus 3x to the 8th minus 3x to the 11 plus dot 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 minus 1 and plus 1, and then 3x to the 3n minus 1 plus dot dot dot. Now here we want to find f of f prime of t square, and so for each of the x's we'll replace it with t square. So this gives us 3 times t to the 4 minus 3 times t to the 10 plus 3 times t to the 16 minus 3 times t to the 22 plus dot 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 minus 1 n plus 1, 3 times t to the 6n minus 2, and so on and so forth. So this gives us f prime of t squared. Now it also wants us to find g of x, which is integral of f prime of t squared within the limit 0 to x. So g of x is equal to the integral within the limit 0 to x of f prime of t squared. So let us do a term by term integration. So f prime is 3 to the 4 minus 3t to the 10 plus 3t to the 16 plus 3t to the 22 minus 1 to the n plus 1, 3 t to the 6n minus 2 dot 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 with respect to t. So the integral of the first term is 3 times t to the 5 over 5. The second term is 3 times t to the 11 over 11 plus 3 t to the 17 over 17 minus 3 t to the 23 over 23 minus 1 3 times t to the 6n minus 1 over 6n minus 1 plus so on and so forth. And obviously we are evaluating this between 0 and x. Now at 0 all the terms become 0, so we don't have to worry about it. So essentially to find this all at x, we can rewrite this as 3 over 5 times x to the 5 minus 3 over 11 times x to the 11 plus 3 over 17 times x to the 17 minus 3 over 23 times x to the 23 plus the general term is 3 over 6n minus 1 times x to the 6n minus 1, and plus so on and so forth. Um, and then it wants us to use the first two terms of the Maclaurin series for g to approximate g of 1. So g of 1, and for the first two terms, so we're going to basically use these two terms. So it'll be 3 over 5 times 1 to the power 5 minus 3 over 11, 1 to the 11, which is equal to 3 over 5 minus 3 over 11, which happens to be 3 times 11 minus 5 over 55, which is equal to 3 times 6 over 55, which is 18 divided by 55. In the last part of the problem, um, it says that the Maclaurin series for G valued at x equal to 1 is a convergent alternating series with individual terms that decrease in absolute value to 0. So, and it wants us to show that the approximation that we did in part C differs from the actual value of g of 1 by 1/5. Okay, while some number that is less than 1/5. So since it is an alternating series, just recall, let's recall one of the properties of an alternating series. If you have an alternating series of this form, okay, which is equal to, u1 minus u2 plus u3 minus u4 plus so on, okay, then what we know is that if we were to approximate it up to a certain number of terms, let's say approximate it up to the nth term, minus 1 to the n, un, okay, then the difference between the value of the thing, so let's say we approximate it up to the nth term, right? So then the difference in the actual value of this sequence, let's just call the sequence um, some h of x, okay, then the difference between h of x minus this thing, okay, the error that is introduced is going to be less than the absolute value of the n plus 1th term, so un plus 1 term. Since the Maclaurin series that we have for G is an alternating series, okay, and its absolute value approaches 0, so we know that the series obviously converges. And since it converges, we can apply the same principle for the series, and we can say that g of x minus s2, which was the approximation that we did in part C, has to be less than the third term of the series. If you look at the series, the third term happens to be the term which is 3 over 17 times x to the power 17. So we know that this is therefore less than 3 over 17 times x to the power 17, but all this is evaluated at x equal to 1. So this is less than 3 over 17 times 1 to the power 17. And we know that 3 over 17 is obviously less than 1 over 5. And so the approximation was better than, okay, is 1 over 5. All right, so that's the end of that problem.